Good afternoon, guys. Today we will see class 3. Okay, what is there in class 3? Remember, we are discussing science and technology. First two classes we have completed. Class 1 we have discussed how to prepare for UPSC science and technology. In class 2 we have discussed some important basic concepts like what is a molecule, what is an atom, what are the particles, etc. These basic concepts we have discussed. Okay. In continuation to that, in this class we will discuss few more basic concepts. Remember, these topics, whatever we are discussing, they are not complete now here. They will work like a base, okay, basis for the future classes that we are going to have elaborately. The aspects that we are going to discuss in an elaborate manner, in a detailed manner. To understand these concepts that we are discussing here in these few classes, 2 to 3 classes, will become basis. Okay, right. As part of it, today we will discuss a few more concepts like energy, heat, and thermodynamics. We will see what these aspects are. Right. First, we will try and understand about the energy, and we will see the core pillars of the energy. Okay, what define the energy. Okay, you see, energy is not simply a resource. It is something that can be transferred and transformed from one form to another form. Remember it, very, very important. It can be transformed from one form to another form, like a potential energy to kinetic energy, like that. Okay, we can convert vice versa also. Okay, so to understand energy, the concept of energy, we will see certain aspects. Okay, so first one is energy. What is energy? The simplest definition of energy is capacity to do work. That's how you will define energy. Energy is simply the capacity to work, the capacity to do work. That is called as energy. Right. Next, you have another concepts like work and power. Okay. So what is work and what is power? The rate and quantity of action are known as power. Okay, power and work. Okay, right. So there is a slight difference between energy and power, right? Then we will come to thermal aspects. Okay, the things related to heat, temperature, etc. So first you see what is heat and what is temperature. Heat is nothing but energy transfer. Energy is being transferred from one body to another body because of the temperature difference. That is called as heat. Temperature, whereas temperature shows the states of two bodies. Okay, how much temperature is that body is having, and how much temperature is this body is having. That's it. Okay. So, in thermodynamics, we are going to see little bit later. There are limitations. Conversion, when we convert energy from one form into another form, not all the energy gets converted. There is some loss of energy in the form of heat that we are going to understand. Okay. So we are all going to see things like conversion and efficiency. You see, because we cannot convert all the energy which is in one form to another form, because there is some loss of energy in the form of heat, comes the question of efficiency. So for example, only 40% of the energy is converted. For example, 100% energy is there. When it is being converted from one form to another form, let's say only 40% of the energy got converted. So what is the rate of efficiency in that case? The rate of efficiency in that case is 40%. Okay, right. Now we see the proper definition. Once again, we will see the definition of energy and its core forms. In what forms you will get energy. Okay, so just before, we have seen energy is the capacity of a system to do work or bring about change. That's how you can define energy, right? Then further, energy exists in different forms that are not isolated. You see, they are not separated from each other. Okay, energy exists in different forms. I think in your lower classes you might have studied kinetic energy, potential energy, etc. Okay. So how technology works? Technology works by converting energy from one form into another form. So for this conversion, technology is required, okay, to convert energy from one form to another form. Right. So first we will see the simpler forms of energy or basic forms that you have studied in your lower classes. Kinetic energy, okay, this is associated with the motion, okay. So moving vehicle, which type of energy it is producing? Kinetic energy, okay. Potential energy, this is associated with the position. For example, dam, behind the dam there is water, so water is having what type of energy here? Potential energy, the energy that is coming because of the position of the object or thing. Then another forms of energy are similarly thermal and chemical energy. So how thermal energy is produced or stored? In the form of microscopic particle interactions. Okay. The next one, chemical. So how chemical energy is stored? It is stored in the molecular bonds. For example, in the fuel cell, in the battery. So we get electricity, energy from there. So how it is stored? It is stored in the bonds, molecular bonds that are there in fuel or in fuel cell or in battery. Okay. Moving forward, another forms of energy are also there. Electrical energy, I think you know it very well. So this is associated with electric charges. Okay, plus and minus electric charges are there. So electrical energy is associated with this positive and negative charges. Then radiant, finally radiant energy is there. It is carried by EM radiation, electromagnetic radiation. For example, sunlight. You see, to sunlight to reach from sun to the earth, no medium is required. So how it is getting transmitted? It is getting transmitted in the form of electromagnetic waves. Okay, that is the significance of radiant energy. Okay, and finally we will come to nuclear energy. In class 2, we have discussed something about nuclear energy. Okay, the forms of nuclear energy, nuclear fission and nuclear fusion we have seen, and how this energy gets released also we have seen. So energy is formed in that manner also. So what is nuclear energy? That is energy associated with the structure and interactions at the atomic nuclei or in the atomic nuclei center of atom. Okay. There are these many diverse forms of interconnected energy forms through and how we convert energy in one form to another form by utilizing the technology. So technology is the media or medium to transform energy from one form into another form. Okay, right. We will move forward. We will see some more concepts. Right, right. Now we will see energy conversion. In some more detail, we will try and understand the conversion of energy. So what is the conversion of energy? Energy conversion is the transformation of energy from one form to another form. Like I told, from kinetic energy to no, potential energy to maybe electromagnetic energy, like that. Okay, conversion of energy from one form to another form, it is called as energy conversion. Okay, so understanding energy conversion is very important for understanding several day-to-day aspects in our life. Okay, to understand many phenomena that are taking place around us, this energy conversion, knowledge about energy conversion is very important. Okay, for example, we will see in hydroelectric power plant what happens. You know, very big dam will be built, water will be stored, then water will be channeled through a route, and that water will spin a turbine, and because of the spinning of the turbine, electric energy will be generated, and that energy will be stored and that is supplied to us, and we are utilizing the energy. So what is happening here? So what is happening in hydroelectric power plant? Potential energy of water is utilized, and that potential energy of water is converted into kinetic energy when the turbine spins, that is kinetic energy. And you can say, I'm sorry, the flow of water is kinetic energy, I'm sorry. water is stored in the dam, then it is made to pass through a channel, then it is getting converted into kinetic energy, and the water, flowing water will spin the turbine when it falls on the turbine. So here the energy is from kinetic form to, it is being converted into mechanical form. Okay, when the turbine is spinning, that is mechanical form of energy. Then finally it will be the turbine uh, uh, will be connected to some other machinery, where this coil will be there, a motor will be there, and this, in that way the mechanical energy will now be converted into electric energy or electrical energy. So this is how energy gets converted from one form to another form in hydroelectric power plant. Remember, very very important. Then solar photovoltaic energy. So what is the process here? Solar radiation, it will gets transmitted onto the earth in the form of electromagnetic waves, and here on earth, by using solar panels, okay, solar photovoltaic panels or cells, we convert this solar radiation into electrical energy. Okay, so the desirable form in most of the cases, you remember, it is the electrical energy. Okay, and based on that electrical energy, then we have several applications in our day-to-day life. Then in the internal combustion engine, you might have seen, where you will find internal combustion engine in all the vehicles. Now you see, if you leave out electric vehicles, in all diesel and petrol and vehicles, even in CNG also, you will see the internal combustion engine. What is the meaning of it? Within the vehicle, there is an engine which combust, means burns the fuel, like petrol, diesel, CNG, etc. So what is the process here? Here, the chemical energy that is there in the form of petrol, diesel, CNG, etc., it is getting burnt and it is being converted into thermal energy, heat. Then finally, it is being that heat is being converted into mechanical energy. So what is the mechanical energy when the vehicle is moving? That is the mechanical energy. So this is what happens in the vehicles, internal combustion engines. Battery, in battery you will see chemical energy is stored in the form of chemical energy, and from that electrical energy will be released. And in battery it can be done vice versa also, means electrical energy can be converted into chemical energy also. Okay, right. So where it operates, it broadly operates as chemical storage that discharges electrical energy. So batteries, AA battery, AAA battery, you might have seen, their energy is stored in the form of chemical energy. Okay, so finally we will see the electronic motor or electric motor, EVs. Nowadays we are seeing here electrical energy is being directly converted into mechanical energy. Okay, so there is no internal combustion engine in electric vehicles. Simply you will store in energy in the form of electricity in battery, then that will be, we retrieve that and we convert it into mechanical energy. Okay, so this is conversion of energy, very very important. Then we will see the laws of conversion of energy, very very important. Three laws are there. Okay, first law of conversion of energy, sorry, three laws of thermodynamics are there, we will see them later. Here we will see the law of conversion of energy. Simply the law says that total energy in a system, means in the universe, you can say in a system, is permanent, means it cannot be destroyed, energy cannot be destroyed. So what we can do at max, we can transform energy from one form into another form. That is what we can do. We cannot destroy the energy, we cannot create the energy also. So what we are doing at our best, just we are converting energy from one form into another form. Very interesting. We will see it. Then there is a concept of enthalpy. Then I will explain it. What is the meaning of enthalpy? So energy cannot not simply be created or destroyed. Okay, like I told, it can only be transferred or transformed from one form into another form. Okay, so this fundamental principle provides the foundation for understanding all energy systems. Okay, so whether it is biological energy, chemical energy, electrical energy, okay, kinetic energy, potential energy, just you are transforming it from one form into another form. Okay, so for example, we will see petrol conversion. So when petrol is burnt in an engine, chemical energy does not disappear. It is converted into useful mechanical energy. Okay, the wheels are moving, wheels are rotating. Okay, and they are driving the motion. Then thermal energy. Okay, so dissipated heat. In the process, some heat is also being generated. That is also, so the chemical energy is transformed into some heat. But remember, heat here we are not using. We doesn't want heat. So it's kind of unused energy, you can say, or wasted energy. In other words, you can say. Okay. Then in the form of sound and other losses also to the surroundings, some of the energy got transmitted or transformed. Okay, right. Second example, let me give you electricity generation. So what is happening in electricity generation? When electricity is generated in a power plant, the original energy source, whether it is coal, okay, fossil fuel source, coal, or wind, or renewable energy source, or nuclear, or water, it is transformed into electrical energy. The energy that was there in these forms, it is getting transformed into electrical energy. So every stage of generation represents a shift in energy state, keeping the global energy strictly constant. Okay, that is the understanding we have to make here. So but one thing we have to understand is conversion, conservation versus utility. So how much of the energy that is transformed or converted, okay, or transformed from one form into another form. So why we are transforming it? For our utility. So how much of the transformed energy is used? That is the biggest question. So that is called as efficiency, like I told. So conversion of energy does not mean that all input energy becomes equally useful output energy. So not all input energy is used by the person who is trying to use it. Some of the energy is being lost in the form of heat, in the form of sound, etc. Okay, and this is not available for utilization by the person. Okay, so as energy transforms, it naturally disperses into less accessible forms like waste, heat. Okay, this brings us to the core engineering challenge of efficiency. Like I told, if you are able to, if some quantity of petrol is burnt, not all the energy that is being generated in a bike is utilized. Some of that energy is being wasted in the form of heat, and sometimes we are applying brakes, then also some of the energy is lost. Okay, in that way there is some loss, and which is not useful for us. So there comes the issue of efficiency. Okay, so how much percentage of the energy that is converted or transformed you are using, that is what is called as efficiency of the system, right? Then we will try and understand the concepts of energy and power. So what are energy and power? Energy and power are closely related, but they should not be confused as a same. Okay, so energy refers to the capacity to perform work. Okay, and whereas power refers to, or the power measures the rate at which that work is delivered. So for in 1 hour how much work is done, in 2 hours how much work is done, in one day how much work is done, that is what is called as power. Whereas energy, it's just the capacity to a work. And power is when you are comparing that work according to the time, in this much time how much work is done, then you call that as power. So energy refers to the amount of work that can be done or change that can occur. So what is the unit? May not be that much useful for UPSC students, but still, because we are studying the basics, we will see these also. So SI unit for energy is joule. So energy, simply you remember how much. Power, it refers to the rate at which energy is transmitted or work is done. So what are the units for it? The units for it are watt, W. So power is how fast a work is being done. Okay, right. So this is the simple difference between power and energy. Okay, right. We'll move forward. heat and temperature. Now we will come to another concept, that is heat and temperature. So heat and temperature are not the same things like energy and work. So temperature describes a thermal condition of a system, whereas heat describes the actual transfer of thermal energy from one object to another object. Okay, so what is temperature? Temperature indicates the thermal state of a system. It is related to the average microscopic kinetic energy of its particles. So within the material also, the particles will be continuously moving around. They are not stable. Because of that movement, what happens? One collide with each other, and energy, heat is being generated because of that. So that is called as temperature of that particular system or material or matter. What is heat? Heat refers to the energy transferred between systems. Okay, right. So this is driven entirely by a difference in temperature between two systems. For example, hot water is there in the bucket. I'm touching with my hand. Okay, so I feel that my hands are burnt. So why it happened like that? Because the temperature of the water is very high. My body's temperature is relatively less compared to that. So when I touch it, the energy that is there in that hot water is trying to get into my body, and because of, but my body is unable to tolerate it. Because of that I feel pain. Okay, so what is happening here? It's trying to get transmitted. Simple example, stove is there, gas stove. You have lighten the stove, you have put bowl and put water. So when you are boiling the water, what is happening? Actually, the heat or temperature that is there in the flame, it's getting transmitted into the water, and that's why water is getting heated. Okay, so this is what is heat. Okay, right. So the transfer example, if a hot object is placed next to a colder one, energy is transferred to the colder object in the form of heat. So simple example I gave. Okay, so this transfer continues until where? Until the temperature of both the objects is equal. Up to that, the heat keeps on getting transmitted. So the transfer continues dynamically until thermal equilibrium is approached. Means temperature of these two systems becomes equal. Up to that time, the temperature, the heat keeps on getting transmitted. Okay, right. So now we will understand how this heat is actually getting transferred. So three types of transmissions are there. Energy transmissions or temperature transmissions are there. I think in lower classes you might have studied. The first one is conduction, second one is convection, and the third one is radiation. Okay, so for these two, conduction and convection, you need a medium. For radiation, there is no need for a media or medium, okay, through which the heat can be transferred. So conduction, what is convection? Heat is transferred through a material by interaction among the particles without bulk movement of the material. So for example, this is an iron rod, we will see it. So just I am heating this part, but over a period of time the entire rod gets heated. How it is happening? Because the particles or molecules that are there in this water body, uh, iron tool, it's getting transmitted. Okay, slightly the particles are moving and they are transmitting heat from here to here, here to here, like that. The entire iron iron thing gets heated. That is called as conduction. Okay, so it is happening because of the interactions among the particles within the system. That is called as convection, sorry, that is called as conduction. Okay, so generally where conduction happens, it happens in solid materials or solid systems, you can say. Okay, right. So what are the key characteristics of conduction? Metals are generally excellent conductors of heat due to free electrons. So because in metals free electrons are there, they will move, they will transfer heat, okay, from one point to another point. That's why metals work as very good or excellent conductors of heat. Okay, right. Second one is convection. So you can say convection happens in liquid systems and also in gaseous systems. Okay, so how heat is transferred here? It is transferred through the bulk movement of a fluid, whether it is liquid or gas. Okay, that is driven by density difference. Okay, I think when the particles are heated, their density decreases, and because of that their mass or weight gets decreased, so they will go above, and the higher density things will come down and they will start receiving the heat. So this is a continuous process. Convection can be shown like this. Okay, so like this, when you boil the water in a pot and you have put flame like this, for example this is the water. So how water gets boiled? The water here gets heated, and it will, because it becomes less dense, it will move up, and the water that is there here already, because of its high density, it will come down, and then it starts receiving the heat. Okay, so this system is called as convection. Okay, so it happens in liquids and gases. Okay, then where you will see, generally see, in atmospheric circulation, in ocean currents, in boilers and cooking systems, you will see convection. Few examples. Then finally we will see radiation. Here what happens in radiation? Heat transfer occurs through electromagnetic radiation, EM. Okay, so unlike conduction and convection, radiation doesn't require a material or medium for transmitting this heat. So generally where you will see, the sun's energy reaches earth, between sun and earth, to a great extent there is no medium at all, there is nothing. Okay, only vacuum is there, but still energy gets transmitted in the form of radiation. So how it is getting transmitted? In the form of electromagnetic waves. Okay, that is radiation. So conduction, convection and radiation, I hope you will remember. Right, so finally we will see the concept of thermodynamics. Okay, so what is thermodynamics? It is the branch of physics that is concerned with energy, heat, work, and transformations of heat, transformations of energy. Okay, so it provides the foundation for modern technology without needing advanced math. Okay, that is the subject of thermodynamics. Okay, core applications, if you see, thermodynamics serve as the core framework for engineering and industrial design. It provides the essential rules governing several things, including power plants and turbines, energy and energy conversion, refrigerators and heat pumps, industrial processes. Okay, so with respect to thermodynamics, three core principles are there. Earlier I have mentioned them. So we just know what are these three principles. That's more than enough for us from the UPSC perspective. You need not go into complex explanations. Okay, so, complex, physics principles, etc., etc. So first is something related to energy conserved. So what is the first principle of thermodynamics? The total energy in any isolated system remains constant. It only changes state. It changes from one state to another state. Okay, this is the first principle. Second principle is conversion limitation. It Second principle talks about the limitations on conversion. So no process is 100% efficient when we converting energy from one form into another form. Energy is inevitably decreases due to less accessible form. So the energy that is there in non-accessible form is called as entropy. Okay, so why we worry about energy resources are declining? In the process of utilizing energy resources, lot of energy is becoming into the form of non-usable form. It is becoming it is transmitted into, or it is getting converted into non-usable form. Okay, and that is called as entropy. So what is non usable form? Because of the excessive utilization of these fossil fuels, now the global overall earth's temperature has increased, the atmosphere temperature has increased. Why it has increased? Because of the excessive heat in the atmosphere. So where this heat has come, when we are trying to transform this chemical energy that is there in the petrol and diesel, when we burnt it, all that energy which has come out, we did not utilize it. Some of it has escaped in the form of heat, and that heat is no more useful for us. We cannot utilize it. Still it is energy, you remember. And instead of providing some we utilizing it, it is leading to some unwanted consequences. So that's why it's called as unwanted energy, is called unutilized energy, or energy that is in the form of unutilized condition is called as entropy. And unfortunately entropy is continuously increasing on our earth. Okay, right. So that is what the third principle is. Entropy increases. So physical processes in isolated systems naturally tend towards disorder over a period of time. So all the energy will become at a point of time, all, if we are not careful, all the energy will go into the, or gets converted into the form that we can no longer utilize it. Maybe the energy or the heat that is trapped in our atmosphere, we can no longer utilize it. Okay, so that is the problem of entropy, and this suggests disorder in the system of energy. Okay, right. So these are the three principles you have to know from the UPSC perspective. Okay, so that is the first law of thermodynamics. Already we have seen briefly. So first law is an expression of the conversion of energy applied to thermodynamic systems. It indicates that energy supplied to a system must be perfectly accounted for between internal state changes and external work. Okay, so this is what is the first principle. Then we will see the second principle. The second law introduces an important limitation on energy conversion. So although energy is conserved, not all energy can be converted into useful work with 100% efficiency. So that is what is second law of thermodynamics. Okay, right. Then the third one is, it speaks about efficiency and entropy. So efficiency indicates how effectively a system converts input energy to useful output. It is a useful critical metric for sustainable energy transformations or transitions, dictating that higher efficiency requires less input for the same work. Okay, right. So then here also comes the concept of entropy. I have already explained it. Here examples are there, and finally how it leads to the chaos or disorderliness in the system, because lot of energy gets transformed into unusable form of energy. Okay, and this leads to what should I say, instability in the system. Okay, so these are the three laws of thermodynamics. Okay, and finally we will see why actually this efficiency matters. Okay, for energy security, not only for our use but for future generations also, we have to conserve energy. So how it becomes important? Energy efficiency is the ultimate first fuel. Saving energy is often significantly more economical, secure, and environmentally beneficial than producing additional power from new sources. So that's why it is said that producing 1.5 unit of energy is actually equal to saving 1 unit of energy. Okay, so if you are saving energy, that's very, very, very important. Okay, so how we have to mitigate the loss of energy? So energy resources are structurally limited, and convergence always involve inherent losses. Improving efficiency directly mitigates these vulnerabilities, offering cascading advantages. So several advantages are there. You can reduce the pollution, you can reduce the global warming. Okay, you need not burn that much fossil fuels, etc. Okay, so we can reduce the fuel consumption, we can lower the energy imports from other countries. For example, you see the condition of India. Okay, now crude oil is going to cross $100 per barrel. Okay, within few days, prices are increasing like anything. That can, problems like that can be avoided. Then we can decrease the emissions actually, which are creating pollution in the environment. Then we can also lower the operating costs for several industries. Okay, right. So how we can actually achieve efficiency? We can achieve efficiency by achieving reduce conserving the energy in vehicle efficiency, or the vehicle is utilizing all the energy that is being produced, okay, in the internal combustion engine. Industrial machinery also, we have to put in place efficient machines which utilize the maximum possible energy. Then building insulation. Okay, when we use coolers, okay, or heaters, the buildings should be properly insulated so that the heat or cold do not escapes. Okay, or will not escape. Then in electric motors also, in power transmission also, we have to reduce the transmission and distribution losses. Then in several electronic appliances, even mechanical appliances, we can conserve energy. It is possible. Okay, it is doable. Right. So right now we will see what is an heat engine and a power generation. What is heat engine? Heat engine converts thermal energy into mechanical work. Best example, let me tell you, a train. Okay. Earlier, how the trains used to run? Simple. We used to burn the coal, heat is generated, and with that heat, we used to generate moisture. We used to, boil the water. Water vapor is generated, and that pushes the engine, rail engine. Okay. So in this way, thermal energy is getting converted into mechanical work, mechanical energy. The train is getting moved, right? That is mechanical energy. So this is called as heat engine, where thermal energy is getting transmitted into mechanical energy. So the general thermodynamic process is driven by the transfer of heat from a source to produce useful mechanical output, and along with that some waste is also being generated. So examples are like I gave steam turbine. Okay, that we see in railways, etc. Okay, in thermal power plants also we are seeing. Then second example is internal combustion engines in traditional, all traditional vehicles except electric vehicles. Then gas turbines. All these are examples of heat engine. Okay. All right. Then we will see thermal power generation. What is thermal power generation? Energy, the source of energy differs, but the downstream energy conversion process is broadly similar. What is it? Heat energy or thermal energy getting converted into electrical energy. That is thermal power generation. So, fuel input generally, whether it is coal, whether it is nuclear material, whether it is gas, it is burnt, and heat, with that heat we generate water vapor, and water vapor has lot of energy, and it pushes something, it spins the turbine, and in that way electrical energy is being generated. So the source energy for thermal can be anything. It can be coal, it can be gas, it can be nuclear, this thing also, nuclear material also, radioactive material. It can be even waste also. Now we are talking about waste to energy. Here what is happening? We are burning the waste and generating the energy, and from that energy now we are getting the electrical energy. Okay, so this is what is called as thermal power generation. Thermal power generation served us like anything, but gradually we are moving away from it. Now what we are talking about? We are talking about not thermal energy but renewable energy. Okay. Getting energy from solar, getting energy from wind, getting energy from biomass. That is what we are talking about. Okay. Right. So fuel input, it will be burned first, then steam or gas will be generated, and that steam or gas will push the or spin the turbine and generated. In that way, electrical energy will be generated. Okay, that is the form. So coal versus nuclear debate we will see in future classes. Coal is considered as dirty fuel. So sometime somewhere in our past we have started utilizing nuclear material to generate that heat instead of coal, and now questions are being raised about nuclear material also. So we will see all these things in the advanced classes. Okay. Then finally renewable energy and conversion. So instead of using these traditional sources like coal, gas, etc., now what we are talking about? We are talking about solar energy, wind energy, biomass energy, etc., etc. So in solar energy we use solar photovoltaic plates, and okay, we utilize the radiation, and with some chemical reaction electrical energy will be generated. Okay. Wind also, we use the kinetic wind power, and we spin the blades of the windmill, and that further spins the turbine, and turbine is connected to generated, and in that way electrical energy is generated. That is also a clean energy. Wind energy is also clean energy. And biomass energy, what is happening in biomass energy? It is stored chemical energy in biomass. It is converted through direct combustion thermal pathways or secondary chemical conversion processes. Okay, so biomass energy is stored in the form of chemical energy, and by burning it or through some other process we are transmitting into, or we are converting it into electrical energy, and later into mechanical energy. Okay. Right. So best examples are wind power and for examples for mechanical and kinetic convergence. For wind power, mechanical energy is converted into electrical energy. In hydropower, potential and kinetic energy is converted into electrical energy. Okay, so this is how electrical energy being produced by using the various sources. Okay, these are renewable sources and these are traditional or non-renewable sources, conventional sources or non-renewable sources. Okay, right. Then the emerging technologies are batteries which store the energy in the form of chemical energy. Okay, and you directly get energy from either from fuel cell or from battery. In batteries, actually, electrical energy itself is stored. In a fuel cell, it is stored in the form of chemical energy. Okay, so that also you will study in the future, but we did not crack it completely. Batteries, we did not find, create, until now we did not create, sufficient batteries with sufficient capacity to store all the energy that is being produced. Okay, storage is a problem, especially for renewable energy sources. We will discuss about them in the future classes. Okay, don't worry about it. Okay, so then hydrogen, and the technology of future is hydrogen and hydrogen fuel cell. Here what you will do, simply you will use hydrogen and you will use oxygen also. With that you will generate electricity, and it has very limited waste also. What is the waste you will get? Actually, it is, you will get water plus some heat as waste. So hydrogen is going to be the future of energy of future. Okay, either hydrogen fuel cell you are going to utilize, or just you will burn hydrogen. Okay, and from that you will get lot of energy. So hydrogen is going to be the energy of for the future. And about hydrogen and hydrogen fuel cell, already questions have been asked in the prelims examination. We will discuss elaborately about hydrogen and hydrogen fuel cell in the advanced classes. Okay, so this is also one of the important sources of energy. Okay, then solar energy and earth systems also we will discuss in the future, all the complex aspects related to solar energy, etc., etc. What is its potential, whether it is going to solve the problem, meet our needs of the future generations, etc., etc. Everything we will discuss in detail in the future advanced classes when we discuss renewable energy and energy conversion. Okay, right. Right. Some questions are there for your practice, prelims questions. 3 questions I have given. Please go through the questions, pause and go through the questions. And some for your practice, I have also given 2 mains questions. Pause the video and try to answer the mains questions also. Okay, they'll become important for your practice. Okay, this is what you have to know in this chapter. Small chapter but very important chapter to understand the basics. Right. So this is it for today. See you next time. And if you want the material, reading material, please message me. I'll share the PPT and the associated reading material for you. Okay. So this is it for today. See you next time. Until then, you have a very good time.